Hello, my name is Luca. I work for the IoG education team, and in this lecture I want to talk a bit about the Cardano CLI. So what this lecture will be about, first I want to present the Cardano CLI GUI tool. This will be the main topic of the lecture. Then after that I want to talk a bit about how to use the Cardano CLI by hand, where you can use multiple inputs and outputs, transaction inputs and outputs. Then I want to showcase the Cardano CLI help. I will also talk a bit about balancing transactions by hand. And at the end of the video, I will talk about the downsides of the Cardano CLI. So let's get started. What you will need, if you want to follow this presentation, is the VS Code editor with the dev container that was prepared for the Plutus Pioneer program, fourth iteration. And you will also need this repository. It's at the input-output HK GitHub page, and it's called Cardano CLI GUI. So this repository you will have to clone to your operating system, because this GUI doesn't work from inside the dev container. You will have to install it manually. And there are two ways. You can either follow this instruction and run the GUI by hand, or you can also use executable files that you can find here in the executable folder. Currently there are only files for Linux and Windows. Also for macOS there will be an executable file added later. And one thing to mention is that it's a good idea to run this GUI on Unix style OS, because on Windows it can happen that some fonts and sizes get distorted. In case you are using NixOS, there is also a shell.nix script provided and some short instructions what you have to do to run the GUI on NixOS. Another thing to mention is in order to run the Cardano CLI GUI, you will also need to install the Cardano node. The instructions can also be found here, and we will go now through them step by step. So the instructions how to install a Cardano node start here. It says in order to run a Cardano node, you have to download it from here. You can click on the link, and it redirects us to the GitHub page of the Cardano node. And if we scroll a bit down, we see that at the end of the page there are the installer files. You can find it under static binaries. So for instance, if you click on Linux, it starts to download the binaries for Linux. What you will also need are the configuration files. So it says then download the configuration files for the preview testnet from here, or for the production mainnet from here. We will use now the testnet. So we click also on this link, and we can zoom a bit in, and we see here is the preview testnet, and those are the 7 configuration files you will need. You will also have to download this. There is also a pre-production testnet, but we will stick to the preview testnet since it's synced faster than the pre-production testnet. So I did this already, and I downloaded everything to my Fedora OS. I am virtualizing Linux, and I put everything inside the Cardano folder. So in this folder, you can find the Cardano node folder, where I download all the binaries from the Cardano node. What you have to do, you have to also put these binaries at a location that then they are accessible to the user. So let's check it out. I put them at /user/local/bin. So then I can run Cardano CLI /help, and I see it works. The command is accessible. Let us look now also at the configuration files. I put them in the Cardano node run folder. So these are all the configuration files. And I also created the start node testnet script. So this script is used to start the Cardano node. You can find these commands also on the GitHub page of the Cardano CLI GUI. You see, these are the commands: Cardano node run, then it takes in some configuration file, database path, node socket, socket path, also address port and config.json. You will also need the node socket file. This file gets created once you first start the node, so when you run this shell script. Once this is done, you can stop the Cardano node, and you will have to go on Linux to your bashrc file. So let's look at the .bashrc file, and you will have to add this line at the end of your bashrc file. So you export the variable Cardano underscore node underscore socket underscore path, and in this variable you have to point to this node socket file. This is important, so then the Cardano CLI also works accordingly. Once you have done this, you also need to source the bashrc file, and now everything should work. Now you can start the Cardano node and wait until it syncs. So let's go to this location, Cardano node, run, and let's start it. So the Cardano node needs some time until it gets synced, and we will now look at the Cardano CLI GUI and show you how you can check how much the Cardano node is synced. Let's close this. Here first we need to clone the repository of the Cardano CLI GUI. So let's open the terminal, clone, go back to the GitHub page, copy the link, and clone this repository. It takes some time, maybe half a minute, because the executable files for the GUI are around 50 to 60 megabytes large. We already see the folder here got created, the Cardano CLI GUI, and it's almost finished. Okay, let's cd into the folder, CLI GUI. So here we see we have the Python script, Cardano CLI GUI. We could run it by hand, or we can also go into the executable folder and simply start Cardano CLI. I am on Linux, so I will take the Linux executable and start the GUI. Okay, so we see the GUI appeared. So at the top of the GUI it says to unlock other tabs, set a valid folder path, or files will be loaded or saved to this folder. I have already prepared a folder, it's called Cardano CLI testing, and I have already some files in it that we will use. So let's check what is this folder path. Okay, copy this. Here. And we see other tabs now got unlocked. Also here it says current folder path set to, and the folder path is written out. Below this we can see it's written debug mode off. If the debug mode is on, the programming prints the Cardano CLI commands to the terminal instead of executing them. So we will in this presentation also use the debug mode, and you can set it here in the debug menu. So if I put it to on, I get a notification, debug mode set to on, and here also the label changes. But first we will actually execute the comments, and then later we will show how they work in the debug mode. At the bottom, there's written a Cardano node has to be synced and running for the query and send comments to work. So we said previously we can check with the GUI how much the Cardano node is synced, and we can do this by going to the query tab. And here we have to select whether we are on mainnet or testnet. We select testnet, and we click on the query info button. So now we get some information of the testnet. We see the current block, the epoch, the era we are in, hash, and the slot. And at the end it's written the sync progress. So currently our Cardano node is fully synced. When you see 100, it means that you can start using the GUI and everything should work. Okay, so now let's start first with the wallet tab. We see we can input a verification key name and a signing key name. We have the option to set them or to generate both keys. In this folder I already have a 01 address file, public key hash file, signing key and verification key, and then the same for 02. So let's first input 01, the key. I can click on set, verification key file successfully set. And now that I have set this, I could, for instance, generate a payment address, but we already have the address file of 01, so we can say 01 address set, select testnet, and we click on show, we get the address displayed. And it's similar for the public key hash. Set. Okay. And here we can display it. So this is how you can view information about existing files, but you could also generate those files. And if I click here now and generate both keys, I see the new number 04 appeared. And also here, the files 04 ASCII and VKey appear. Now, for those verification and signing key files, I can now also generate a payment address. And if I click on generate, I see here it's 04 address and also 04.address file appeared. I can click now on show, and the address gets updated. I can do this same for the payment public key hash. I can click on generate, see 04, and if I click on show, now the new key hash gets displayed. So this is how you can generate these files. And now let's look how this works if we run in debug mode. So let's put debug mode to on. Okay. And the comments will be now displayed in the terminal. It's a bit larger. And if I click now on generate both keys, I see first the comment below is defined in pyfile/wallet.py line 190. So in case you are a Python developer, you can also look at the source code and modify something for this comment. And now the actual comment, we see Cardano-CLI, address key-gen, means key generation. And now it picked the name 05, that would be the next file. So verification key file 05 would be generated, and signing key file also 05 ASCII would be generated. We can do now also this for generating the payment address. We click on generate. Address file with the same name as verification key already exists. So it means we already have a 04, and it picks then the next empty one would be 03. Click on close, but this is now in debug mode, so nothing gets actually generated. We only see the comment Cardano CLI address build, takes in a payment verification key file, which is currently above is set to 04, and because the address file 04 already exists, it picks the next empty number and it would pick 03 address. And now we can do this also for the payment public key hash. We get the same notification that the 04.pkh is already taken and it will generate 03. And here we see the comment Cardano CLI address key hash. It takes in a payment verification key file and it produces file 03pkh. So this is how in the debug mode you can view which comments are actually executed in the background when you click on these buttons. So let us put now back the GUI into standard mode. We put the debug mode to off. And we can now look at the transaction tab. So in the transaction tab, it says send funds from your address to another address. And we see we already have the 01 address files in this folder. It's a bit smaller. And I can first check if there are any funds in this address. So I click 01 address, I set it. I select testnet. And I can now click here on query funds. So we see at this address there is already one UTXO sitting. And this is the transaction hash of the UTXO transaction index, and here is the amount. So currently here is sitting 8,577 ADA and some numbers. We also generated the address 04. So let's check if there is something there. And as expected, this address is empty because we have just generated it and there should be no funds sitting in this address. Now let's say we want to send some funds to the 04 address. Here it's written typing your address name will be also used as change address. This means that if we want to send funds from address 01, then the whole UTXO will be spent and some ADA will be sent to the address we specify and the change will go back to this address. So let's select ADA. Let's say we want to send 10 ADA, input receiving address name, 04 address, input UTXO from sending address. So we can again query it. Now we can copy this. So this UTXO will now be spent. Transaction index is 1. And type in your signing key name. This is the signing key from address 1, which has to sign because we are spending the UTXO sitting at address 1. Now, in order to send this, we have to set all these fields, but you can also click on the set all button and then everything gets checked again. Address file successfully set, signing key. In case you would type in some incorrect information, as for instance, this hash is 64 characters long. If I would add another character, let's say 1, and try to set it, I will get a notification message that it has to be 64 characters long and I have to enter a valid transaction hash. So there are some checks performed in the background. And you will see it with the notification messages if you type in some incorrect information. So now we have everything set and we can now click on send. And we see send transaction successfully submitted. And in the command line, we also see the output estimated transaction fee, how much loveless, and transaction successfully submitted. Okay. So now we can look at address 04. Let's say set. And if we query it, we already see there is a new UTXO. And it contains the 10 ADA that we have just sent to it. So this is how this transaction tab works. You can send some ADA from one payment address to another. Okay, so now that we have seen this works, we can look at which commands are actually executed in the background. So we can switch the debug mode to on. And now if we click the send button, so here we see the commands that were executed. First, the Cardano CLI transaction build. So we have first to build transaction. It takes in which era we are in. So then it takes in the testnet magic number. The number 2 is for the preview testnet. So if you would be working on the pre-production testnet, you could set this number to 1. And you can set the era and the testnet magic number in the developers tab. So here we see input testnet magic number. We could say 1. And now the testnet magic number is set to 1. And we could also do the same if we want to use a different era. But if you are not sure about this, it's best to work with the default values. So we can restore them, and now we see again current testnet magic set to 2 and current era set to Babbage era. Let's go back. Then it takes in transaction input, so this is the UTXO that we have inputted. Then transaction output, this is the address where the funds are going to, so 10 million Loveless, which is 10 ADA. The change address, this is the address number 1, 01 address, and in the end it outputs a TX body file. So after that, when we have built the transaction, we can then sign the transaction. It takes in this TX body file and our signing key and the testnet magic number, and it outputs a TX signed file. So with this file, you can also query the transaction on the Cardano Explorer webpage, and you can do this by going to the query tab, and it says show transaction hash for TX signed file. So in this folder we see for our last transaction that we submitted, these two files got created, the TX body file and TX signed file. And if we click now here on show, we see this command will be executed, Cardano CLI, transaction, TXID, and it takes in the TX signed file. So let's do this now. Let's turn the debug mode to off and click on show. And we see here is a link to the Cardano scan webpage. So we can copy this and open up our browser. So if we zoom in a bit, we see we have sent 8.5 ADA and the fees were 0.16 ADA. So together this is 10 ADA. And this is the transaction hash. And here you can see we sent it from this address, which was 01 address. And it came to this address. So actually we sent 10 ADA and then the fees, the additional fees 0.16 ADA were extracted from address 1. And here in this link you can see that also the hash is included in the link. So this is the hash of the transaction. And the last command that was executed when we send the funds is the Cardano CLI transaction submit command. So this command takes in the TX signed file and just submits it to the network. And that's basically it. So this is what happened when we clicked on the send button. Okay, so this was now the transaction tab. Let us now look at the smart contracts -send tab, where we can send funds to actual smart contract. So in this tab it says generate Cardano script address and send funds to it. And first we need to type in the script file name. You can get a script file in VS Code. You are running the dev container for the Plutus Pioneer program. And if we go to the code folder, and we will use the week 3 example, under lecture, you can click on vesting. And here we see this is now the vesting script. And at the bottom, we have some helper functions where we can generate the script file. So the save val function generates the vesting.plutus script. We can go and see the code. We say combine repo. It starts up the combine repo and we import the vesting model. And now we simply run save val. And we see the script gets saved to the folder at the current location /assets/vesting.plutus. We can have a look at this /assets/vesting.plutus. And this is now the script file. We need this script file in order that we can send some transactions to it. And I already copied this on my virtual machine, so you can see here vesting.plutus. Let us now input this vesting.plutus. Also, the file name extensions are checked. So if I would input here something like vesting.plutus1 and set it, say script file does not exist, please enter a valid file name. Or if I would also change this to plutus.1, then it says, now it's set. So actually, it doesn't matter what is the extension file name, just that the actual file does exist. So let us set this back. Rename. Okay. And set it. So next, we can input the script address file name, and we don't have this file yet, so we can click on generate. Select, now it notifies us. We first have to select the option mainnet or testnet. So let's select testnet. Click on generate. And now we see the vesting.address got generated. So this is this file. And we can also click here on show. And you see this is now the actual address of the vesting.plutus script. So if we want to send some funds to it, we have to type in our change address name. Let's say we will send from address 01. Then we need to type in our signing key name, signing key file name, 01 is key. Let's say we want to send 12.3 ADA. And we have to input UTXO address. So this is the UTXO that we want to spend. And we can go to the query tab. And here we can also query the UTXOs for a certain address. So let's say 01 address, say set, click on query. And we see this is the address that has around 8,500 ADA. So we can use this UTXO, and the transaction index is 1. And now we have to optionally choose datum, file type, and file name. And the datum we also get with the help of our VS Code editor. So if we click again on the vesting example, we see there are some helper functions that help us to create the datum. So this function, print vesting datum JSON, takes in a pub key hash and a string, and it writes out the datum to the terminal. So this public key hash is the public key hash of the beneficiary, which can then claim these funds. and the string represents the date and time in UTC time, after which the beneficiary can actually claim the funds. So we can now try to generate this datum, and let's say we import first this model, and if we look at the hash type, we see it's just a wrapper around the built-in byte string. So we could now define that we send funds from address 1, and address 4 will be then able to claim these funds. So we need to define the public key hash of address 4. And here we see the constructor is pub key hash. Pub key hash. And before we do this, we also need to set the overloaded strings extension. Strings. So, key hash 4. Hash. And now we can go back to our GUI. And in the wallet tab, you see this is the public key hash wallet number 4. We can copy this. And paste it here. So this is now the public key hash. Next we want to check what is the current time in UTC format. Time. And you see it's 11:12. So let us set the UTC time to 12. And we actually have to do this in an ISO format. So we can say that the time should be something like this. We are now March 19th. And let's set it to 12, 0, 0, 0, 0. And at the end, you can also specify the milliseconds. And you have to end the string with a Z. So this will be now our deadline after which the beneficiary, which is the address 04, can claim the funds. So we can now copy this function. And include public key hash form. And this is now the deadline. And we see this is now the datum that gets constructed. But if you use this datum, the beneficiary won't be able to claim the funds because this conversion doesn't work properly. Here, the actual public key hash has to be specified. And in order that you convert this public key hash file correctly, you need some other helper functions. So the helper function is called bytes from hex, where the hex, which is the public key hash, gets correctly converted. So the actual comment that we will need will be this one. Let's say public key hash 4. And we need to convert it with this byte from hex, and then again to built-in data, and then it will work correctly. So let us go a bit up. We can copy this. Okay. And we can copy this. So let's write it out. Public key hash 4. Key hash $sign to built-in $sign byte count X. Okay, so this is the command that we need. And it says this binding for PTH shadows the existing binding. Okay, maybe we can change variable name. Now it works. And now we can run again in this command. Okay, and now we see, now the actual public key hash gets displayed in the datum and in this field. And this is now what we have to copy, because this will be our datum. Copy this. And I have here already a file vesting-datum.json, so I can open it. And I delete this. And this is now my datum. So this is the beneficiary public key hash. And this is now our deadline. It's in Unix time, so since the Unix epoch, in milliseconds. And we can now close this. And in the smart contract send tab, we can here choose how we want to supply the datum, and we say we want to inline the datum. So we type in here vesting-datum JSON, and we again click on set on. Okay. Okay. So we have now set all the fields. We want to send 12.3 ADA from address 01 to the vesting.Plutus script, and we also specified in our datum. So that address 4 will be the beneficiary and it can claim the funds after 12 o'clock. So let's click now on send. We can also check the output here. And we see transaction successfully submitted. And now we can also query the vesting address to see whether this ADA have arrived. And in the query tab, we can now input vesting.address, set it. And we see at this address there are many UTXOs sitting. So let's have a look if there is one with 12.3 ADA. And this looks already promising. And it has an inline datum. And this could be our UTXO. But we see there is also another one. Let's have a look. So this is actually 123 ADA and this is 12.3. So this is probably our UTXO. Okay. So now we can try to claim these funds. We claim these funds in the smart contracts receive tab. And here we also first have to select option name at our testnet. It says receive funds from a Cardano script address. So first it asks us type in your change address name. This will be the receiving address. Address 04. Type in transaction input from UTXO script address. So this will be the 12.3 ADA. We can check again if there is maybe another UTXO that was created in the meantime. So this is 1.23. So this is the only UTXO with 12.38. So we can use this one. Transaction index is 0. 0. Type in script file name. Plutus. Choose datum file type and type in file name. So we inline the datum, and now we only have to pick the inline datum present option, and we don't have to supply a datum. Type in the redeemer file name. For the redeemer, if we check this script, So this is make vesting validator. This is the actual script. We see that for the redeemer, we actually use unit. And in the assets folder, also there is unit.json defined, and we can copy this and use this file. So I have this already in my folder, unit.json, and I can simply type here unit.json. Type in collateral UTXO from receiving address, so this will be now the UTXO from address 04 that we will use as collateral, and I can query again address 04, and I can use this UTXO as collateral. Type in public key hash file name from receiving address, so 04 public key hash. Choose validity interval, so we say invalid before, and we have to provide this time with slots. So here in the query, if we query the current slot is this one. This corresponds to the time 11:30, so if we try to claim these funds before 12 a.m., this transaction should not work, and we can try to do this. So let's copy this slot number. So this shouldn't work now. And then it says type in protocol parameter file name. So protocol parameters tell you about something about testnet or mainnet, and you can generate this file in the developers tab. So if I select here testnet, I can click on generate, and it says protocol parameters file successfully generated. The name is protocol.json, and we see it also here, protocol.json. So I can use this here now. And in the end, we have to provide the signing key file name. So the receiving address is 04 as key. And now I can click set all. And now we could try to claim the funds, but this should actually not work because the deadline is the current time slot is prior to the deadline, and here we will see an output. Sometimes the GUI outputs this message, which is kind of an error for connection error to the window, but you shouldn't worry about this because the GUI still works. So let's try to submit this. And we see command successfully executed, but in the window it says script debugging blocks deadline not reached. So transactions command failed. And this is how it should behave. So until we reach 12 o'clock at UTC time, this command should actually fail. And now we can wait a bit until the time is 12 o'clock, and then we can try to claim the funds. Okay, so I waited now a bit. Let us check again the time. And the time now is already past 12. So now the transaction should pass, but we need to check what is the current slot. And we click on query info. And we see this is the current slot. We copy it. And we paste it here. So this time interval invalid before this slot should lie now in the deadline that we have set. So we click on set. And we check again the debug mode is turned to off. That's okay. And now we click on submit. And we see command successfully executed and also transaction successfully submitted. So if we check now, address 4 had 10 ADA. So this is what already was sitting at address 4. And now after the claim, there should be an additional UTXO with 12.3 ADA. So let us query address 4, and we see the claim was successful. So we got a little bit less than 12.3 ADA because that was also the transaction fee that was deducted, but the funds actually arrived at address 4. We can also look at the transaction hash. So we see this is the updated hash. It's the same that you see here. And we can use this link and view the transaction on Cardano scan. Go here. Paste the transaction. And we see. So 12.3 ADA were extracted from the vesting address, and at our address 04, 11.95 ADA arrived. And this was the transaction that we made. So this was it. This was more or less what you can do with the GUI. And now let's also look how to build a transaction by hand if you have multiple inputs. So the limitation of this GUI is that there is always one input and one output. But if you want to build a transaction where there are multiple UTXOs as input, you need to do it by hand. Nevertheless, you can still use the GUI in the debug mode to construct the comment and then modify it by hand. And let's do this now. Let's go to the query tab and let's first check what is sitting at address 2. So I had this address already prepared. And we see there are 4 UTXOs sitting in address 2. And let's say that we want now to send all of these funds to address 1. So address 1 is currently, I think, only 1 UTXO. And now we want to send all the funds of address 2 to address 1. And we can do this if we go to the transaction tab and we construct a transaction where we just sent 1 UTXO but then modified the comment by hand. And if we want that the change goes also to address 1, we can put here address 1. Say set. Let's say we also send 10 ADA. Input receiving address name. Also address 1. And now UTXO from sending address. So our sending address will be 02. And we can take the first UTXO. So it has 10.5 ADA. Or maybe if this will be too little. Now we can take the first one. It will be okay. And index 0. And the signing key has now to be the signing key of the second address, because we are spending in UTXO from the second address. So we can click on set all. And now let's put the GUI into debug mode. And let's click send. So here we see the comments that were executed, and we can copy this and create a file. Let's name it shell, for shell comments. And we can now paste in those comments. We can delete the information, so just the Cardano CLI comments are left. So now we have a transaction where we are sending funds from one UTXO to this address, and also the change is going to this address. But we want to spend all of the UTXOs from address 2. So what we can do we can simply copy this line 4 times and input these UTXOs. The second one, the third one, and the last one has the same transaction hash, just number 1 index. So we want to spend now all of these UTXOs, and the fund should go to this address. You also have to take care that this address, together with the amount we are sending, should be in quotation marks. And this is it. This is basically the transaction that will send all funds from address 2 to address 1. So let's try it out. We can input now. Let's open here a new terminal. Let's go to our folder, Cardano CLI testing. So here are all our files. And now we can simply copy this command and hit enter. Okay, so estimated transaction fee. Now we copy the sign command. So we are signing with key 02 because we are spending UTXOs from the second address. Okay. And in the end, we submit the signed transaction. And it says transaction successfully submitted. We can close this. And if we query now again, address 2. Okay, nothing still happens. Let's wait a bit. The GUI is still in debug mode. Now we can set it to off. And we see that all the UTXOs disappeared from address 2. And if we check address 1, it previously had only 1 UTXO. Now there are 3 UTXOs. So here is the 10 ADA that we have sent. And this is the rest of the funds that were sitting at address 2. So this is around 1,133 ADA. So this is how you can construct transactions by hand, and you can help yourself with the GUI and then just add some additional inputs, or you could also add multiple outputs. Nevertheless, balancing here is still done automatically, so the change is calculated if you supply the change address, but this is not always the case. So when you are dealing with native tokens, you also have to take in account that you will need to balance the command by hand. And I want to show you now an example how also this is done. So I found an example online. You can find it at this address, docs.cardano.org/native tokens/getting started. And they show an example how to mint some native tokens. We will learn about this in lecture 5, but we can now just look at the Cardano CLI command, how to send some of these tokens to another address. And here we see send the new native asset to another address. And under point 4, you see they say send 1 MEL coin to the recipient address. So MEL coin is the coin that we have minted, and this is the Cardano CLI command. And they use the build raw option. It gives you a bit more control over your transaction. You can specify the fee, and here they specify an input UTXO, which probably contains also the MEL coin that they have minted previously. And then they specify 2 outputs. And in the outputs, you see, this is some number hash that represents the MEL coin. It's in this format. And they had to input by hand how many MEL coins each of these addresses will receive. So You couldn't use the option change address because for native tokens you have to do this balancing by hand. So the inputs have to be the same as the outputs. And this is one downside of the Cardano CLI. So you cannot directly automatically balance the transaction by hand. So if we look at some other properties of the Cardano CLI, we can say the downsides are shell scripts are tedious to maintain. Balancing of transactions that include native tokens has to be done by hand. So it's a bit cumbersome, it has more steps than the alternatives, and it's also not best for production code. But nevertheless, the Cardano CLI is pretty good as a learning tool, and it provides you a lot of control. We will learn in the next lecture that there are also good alternatives to the Cardano CLI as Cuber and Lucid. And in this lecture, I still want to show you a bit of the Cardano CLI help, how you can use it. So you can type in Cardano CLI --help. And you see here are some comments. So you can then use the address, stake address key, transaction keyword. And what we did until now, we used the transaction keyword. So let's do this. Action. And here we see then it gives you more options. So you can use the build raw, the build command, the sign, witness. There are many things you can do with the Cardano CLI. We have used the build option. So let's use build. Let's type in less. And we see those are now all the command line options for the transaction build command. And if they are input in these squared brackets, they are optional. So this is not mandatory to provide. You can provide this optional. But if they are input in the usual brackets, then this has to be provided. So if you write a Cardano CLI transaction build command, you have to choose either mainnet or testnet. And in this way, you can explore the comments of the Cardano CLI and look which options are available. Of course, there are many options. The GUI just contains a subset of options that are most commonly used, but the Cardano CLI offers you many more things that you can do with it. So this was it for this lecture. Hope you enjoyed it, and also hope to see you in another lecture. Take care. Bye.